All right, guys, welcome to Math Analysis on March 31st. I think days just kind of meld together at this point. So, what we did yesterday was we talked about the derivative rule, or the derivative power rule, right? Which honestly I think makes finding derivatives so much easier because there's kind of a trick to it. You know, we just multiply the coefficient and exponents, and the exponent goes down by 1. You can see here were the answers to 1 and 4 that we did together yesterday, and you guys were to try out 2, 3, 5, and 6. I didn't hear from any of you on having difficulty with those, but if you do let me know about that, then we'll go over it in a future video. So what we're going to talk about today is going to be derivative notation, and we're going to talk about actually using these derivatives to find an individual slope, which we've talked about before, but we're going to talk about how we would write that, and we're going to do it with some of these problems. So first off, we want to know how we write a derivative. Now, you guys are aware that if we were saying this function, we write it as f of x, right? Now, I mean, your paper may have had it as like g of x or h of x, but whatever it is, a function is written as a letter, typically f, of x equals. Now, its derivative has something similar to this. The derivative is written like this. Let me take that out. It's written as f with this little apostrophe of x equals. And then down here it would be the same thing. F of the apostrophe, or x to the apostrophe of x. What this stands for is the derivative of the function f. Now that's one way to write derivative notation. In this class, it's going to be the way we write it. But just for full disclosure's sake, it is also possible to write it like this. D over dx of the original function. So for number 1, it would look like this. The derivative of 8 minus 4x to the third plus 2x to the 8th equals negative 12x squared plus 16x to the 7th. Now, that's a lot to write, right? Like, this is kind of confusing in and of itself because it's got so much stuff going on there. But this means the derivative of. But since we don't have the f there for us to reference the function, we write the actual function itself that we're taking the derivative of. So again, this says the derivative of 8 minus 4x to the third plus 2x to the 8th is this. Now, that's a whole lot to write. I don't want to write that much. So that's why we use this notation. The derivative of f, or the derivative of the function f, is this, just f apostrophe, or g apostrophe, h apostrophe, whatever the original function was. So now that's how we denote derivatives, that we're talking about the derivative. How we denote a specific slope of an x value on the line is very similar. We would write it like this. Let's say we want to find the slope at x equals 4. Then what we would write is the derivative of f at x equals 4 is whatever we find it to be. Now, to find the derivative at any given value of x, all we have to do is plug that value into the equation. This works just like a function, right? Back when we first were talking about reviewing functions, we said if you plug in something where the x originally was in those parentheses, that means you substituted in for x in the problem. So this is no different. We have the f apostrophe, or talking about the derivative of f, of 4. So we would go to the f apostrophe, or the derivative equation, and we would plug in 4 here. Now I'm going to go ahead and do that on the calculator because I definitely cannot do 4 to the 7th in my head. But we have negative 12 times 4, what is that? 4 squared, okay, plus 16 times 4 to the 7th And we get a huge number, but believe it or not, that's the slope at 4. 261,952. That's a heck of a slope. That has to be the closest thing to a vertical line possible, but that's what it is. And this is how we denote the slope at a given x value. We could do this for any given point on the line. What we could do is we could say, what is the slope at 1? And we could do that. We could do the derivative at 1. I don't know why I wrote a -1, but at this point we're just going to run with it, right? Because that's what I wrote. And we do the same thing. -12 times -1 squared plus 16 times -1 to the 7th. I actually think I wrote that wrong in the calculator. And I wrote this one wrong. Calculators are so frustrating sometimes. I'm sorry, guys. We know -1 is squared is just going to be 1. So that's what I'm going to write there. We get -28. Sorry for that whole process. But we end up getting -28 as the slope at the x value of -1. Now, we could graph this if we wanted, but to be honest, graphing a slope of -28 and a slope of positive 261,000 is not gonna actually look like that much. But that's how we do it. We could go to this second problem as well. If we wanted to say find the same thing. We want to find the slope at -1 or the slope at 4, then we can do so. We again just take that number that we want to find the slope of that point, plug it in for x, and solve. I'm going to go ahead and do that here. So we'll start with -1, trying to get everything in frame. So -12 times -1 to the -5th. Typing in negative exponents isn't something we do often, but it works the exact same way as anything else. You just go up into the exponent with the up arrow on the calculator and type in the negative with it. 4 times -1 to the 3rd, and then -3. So we find out the slope at x equals -1 is 5. And then we can do the same thing for 4. So we would just repeat this process with a 4. So -12 times 4 to the -5th plus 4 times 4 to the 3rd minus 3. And we get a crazy number that includes a decimal. And you may be thinking, well, how did that end up with a decimal? We didn't have any decimals in the problem. That seems weird to have a decimal when we didn't have any obvious division. We didn't have any decimals to start with. Now that would round to 253 just because of the 0.98. But where we actually end up with the decimal is the negative exponent. You may remember this from Algebra 2, but in case you don't, a negative exponent actually, instead of making the number larger, it makes it smaller by putting it in the denominator of a fraction. So like 4 to the -2nd, instead of being 16, is 1 over 16, that kind of deal. So yeah, this is how we would solve any given one of these problems. So you were supposed to do 4 of these on your own yesterday, numbers 2, 3, 5, and 6. What I'd like you all to try out today is finding both the slope at -1 for each of them and the slope at 4 for each of them. Find the use their derivatives to find the slope for the x values of -1 and 4 for each of those 4 problems. If you have any difficulties, shoot me an email. We'll talk about it on here tomorrow. And otherwise, I'll see you then.